Today in chemistry, we'll be talking about solutions. What are they and more? Let's start off with a few definitions. What is a solute? A solute is the thing that is being dissolved. That is being dissolved. And a solvent is the thing that does the dissolving. So it's what does the dissolving. So the solvent dissolving. So the solvent dissolves the solute. So an example of this could be, let's say we have a beaker here, and in this beaker we have water. So we have H2O. And outside of our beaker we have this lump of salt, table salt, otherwise commonly known as NaCl. So when we put the salt into the water, what we find is that the salt seems to disappear. So this is our water, and we put the salt inside already, and you won't see it, but there are tiny salt particles spread throughout the water. And what we find is, since the salt disappears, it must be the water that dissolves the salt. And we can call, so this is our salt, NaCl, and the rest, the liquid, is just H2O. So in this case, H2O is our solvent. It does the dissolving. And NaCl is our solute, the one that is being dissolved. So now we know what a solution is made up of. There's a solute, which is a thing that is being dissolved, and the solvent, which does the dissolving. And together they form a solution. Now we can call solutions dilute or concentrated, but these aren't really specific. So here are some actual ways to quantify how much solute we have in our solvent. So first off, something that's commonly used is called molarity. So molarity, often denoted as large M. And it can also be, if we have some element or compound X, then square brackets around X represent the molarity of that substance. So what is molarity? Well, molarity, it's the moles of solute that we have, the moles of solute that we have over the total liters of solution. So in units, we have that molarity is equal to moles of solute over liters of solution, and our units we represent with a large letter case M. So for example, if once again we have our beaker here with water and our salts floating around, then we can ask, how many grams, if we have this question, here's an example question, how many grams of NaCl do we need? Are needed in order to create 2 liters of a 0.25 molarity solution. So here we assume that water is going to be the solvent. So we're given the molarity and we're given the volume in liters. So now all we have to do is calculate how many moles of NaCl we need and divide by the molar mass and multiply by the molar mass in order to get how many grams that we need. So we have 2 liters times 0.25 molarity, which is also, we can also think of this as 0.25 moles per liter times the molar mass of NaCl, which is 58.44 grams per mole of NaCl. So we find that when we calculate it all out, it should come out to 29.2 grams of NaCl are needed. So this might be sort of an example problem regarding molarity, and this is only when we're adding a solid. Okay, that was if we were adding a solid solute to the solvent in order to have a solution. However, what if we have a solution already and we know its molarity, and all we want to do is to dilute that solution? Then we can use a formula where MC, where C stands for concentrated and M is the molarity, V is the volume, is equal to the molarity of the dilute solution times the volume of the dilute solution. And one reason why this holds true, we can see, is when we have molarity times the volume, what we're really doing is molarity is moles of solute over liters of solution, and volume is liters of solution. So when we multiply them together, we get moles of solute. So looking at this equation, we can recognize that when we're only diluting a solution, since we're not adding or subtracting any solute, we're only adding or subtracting solvent, what we find is that the moles of solute never changes. It's only the volume in proportion to the moles of solute that will change. And that's where we get a dilute or more concentrated solution. So here's an example question. How many milliliters of a 6.0 molar solution of HCl is needed to make 500 milliliters of a 0.25 solution. And here it's implied that the 0.25 molarity solution is also of HCl. So once again, we have MCVC equals MdVd. So we're solving for how much milliliters of concentrated solution, so how much volume of our concentrated solution do we need in order to have our dilute solution. So we're solving for Vc. So Vc is equal to MdVd over Mc. So Md is the molarity of our desired dilute solution, so that's 0.25 molarity times the volume, how much of this dilute solution we want, which is 500 milliliters. And you might wonder why we don't have to convert milliliters to liters, but it'll become clear in a second. And MC is the molarity of the concentrated solution, namely 6.0 molarity. And now, if we're looking at the units, we find that we don't need to convert to milliliters because the two molarity, one on top, one on bottom, will cancel out, and we're left with milliliters, and which is our desired unit for our result. So if we put in the numbers, we find that in order to get 500 milliliters of a 0.25 molarity solution, we need 20.8 milliliters. So we need 20 milliliters of our 6.0 solution of HCl. So let's review. When we're talking about solutions, a solute is dissolved. Emphasis on is dissolved. The solvent does the dissolving. does the dissolving? We learned that molarity is a way of representing concentration, and it's moles of solute over liters of solvent. And we went over 2 examples of when we use molarity. One is we're adding solid solute. We can just use the definition of molarity. And one is when we're diluting a known solution. Namely, we already know the concentration of this solution. Then we use the dilution formula, which is MCVC equals MdVd. And just a reminder, solutions is when we have a solute and a solvent. So solute and solvent when together and the solute is dissolved by the solvent, then we have a solution.